That is true. See,
Actually,
No,
it's
This one
by
says-
category. No, it's by
I think
category,
you're
isn't
wrong.
it?
He's right.
So
What do you
like,
mean
if my
category?
if my
Like
test
test
category is like only like 10% out of 20%,
It's 35.
okay, like 20% out of 35%.
Wait,
Oh,
what?
no, it's 50. It's 50.
Oh.
How is it 50
Oh.
and I have a B?
Wait,
Wait, but my
what?
point,
What percent
no,
is
my
this
point
like
is,
test
so like,
Okay.
since my test category is so low
Here we
than
go.
the average, that I just need
You're
like a
gonna get a B.
90%.
I think your logic is correct, but like, okay.
It like makes
Whatever.
sense.
All right, so here we go. We're on page 3 now. The front side of the second page. So 22 to 30 are these problems. So what do we have? What do we have on this page?
On page 3?
Problems 22 to 30.
20.
What do we?
22A.
22A.
Oh,
These
they
are
got
formulas.
Do C.
These are formulas, guys. This should not be hard. Not hard at all. What's the formula for combinations? How do we do it?
Oh,
What's on
wait.
the top?
Wait.
N plus
Square.
N plus 1 factorial goes on the top, and then what goes on the bottom? This is a C problem. So N plus 1 minus 3 factorial and 3 factorial.
Can we just leave it like that?
No. So N plus 1 factorial means what?
N
N
plus
plus 1
N plus 2.
times N times N minus 1. Kids, when you do factorials, the numbers go down. You're subtracting 7 to 6 to 5 to 4. This simplifies to N minus 2 factorial, which is N minus 2, N minus 3, da 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 da. And then 3 factorial is 3 times 2 times 1. So what's going to happen here when you look at what's on the top and what's on the bottom? Everything from the N minus 2 on is going to cancel. And we're left with, this is easy to multiply. What is N plus 1 times N minus 1?
N squared.
N squared minus 1 and then times an N. So N cubed minus N over 6. Alright, so you just gotta know your formulas.
And is that formula given, or we need to know that?
Alright, what else on this page?
23?
Four beads. Okay, just 4 beads. Make a simple necklace. How many arrangements are possible? Well, how many beads are there? 4, but we're doing it in a circle, so it'll be 3 factorial. And then remember, with bracelets, keychains, and necklaces, we have to take into the account that they can be viewed from both sides, and that what you see and what I see are not different. They are the same, just a reflection. So that takes care of that.
And do
So
you want
there
us
aren't very
to
many.
simplify all of these?
Hmm?
Yes?
The answer to this one would just be 3, right?
Oh.
Yeah, you're still looking out, typing it out, really looking out. All right, what else on this page? Married students, suppose that 22% of all college students are married. How many would you expect to be married? So 23% of all college students are married. I pick 8. How many would you expect to be married if I pick 8 of them?
8 times 0.23.
8 times 0.23. So, and then round that off, obviously, to the nearest whole person. So about 2. Okay. Would you regard it as unusual if the sample contained 5 married students? Yeah, because that's significantly higher than my expectation was. What is the probability that 5 or more of the 8 students are married? Okay, so you're picking 8. So we wanna know what's the probability that 5 or 6 or 7 or 8 are married? And all those ors mean I'm gonna be doing separate problems and adding up the answers. Okay, so let's do 5 first. Do 5 first. So there's 8 people, or couples, whatever they are, and I'm gonna pick 5 of them, AC5. And then the probability of being married is 0.23, so the probability of not being married is 0.77. And I want 5 of them to be married, which means 3 aren't. Is that right? Was it the probability of being married? Yes. So this number, whatever this is, when you type all this into your calculator, just be a decimal. That'll be a decimal. We're gonna type that in and get an answer. All right, now, what does 6 look like? Same thing, only it's HC6. And then 0.23 to the 6th and 0.77 to the 2nd. And you'll do the same thing for 7 and the same thing for 8 and then add them all up. These are the kind that sometimes we did backwards. Remember, we did 1 minus. In this case, it's 6 1/2 dozen of another because we're kind of in the middle. So 5 or more, less than 5 are both gonna involve about the same number of cases.
Can we do 29?
29.
These ones always do
George, you should listen up.
All right, so what is going to be our strategy for this problem?
Venn diagram.
Yeah, it's definitely gonna be a Venn diagram. I always think of it, if I have problems where groups of people or something, things are overlapping each other, that's a Venn diagram situation, right? Where you have your 2 balls and they overlap. So what do we got? We actually have 3 balls overlapping. So we have 40 kids, and we have country, and jazz, and opera. 6 like only country. So some of the numbers I can put straight into my chart right there. That goes in there. Because isn't this the only country people right here? 10 liked only jazz, and 1 liked only opera. 3 liked all 3. 20 liked country. You do not put 20 in here because 20 represents the whole circle, so you don't have a place to put it. Jazz is 22, and opera is 16. All right, so I'm gonna reach in and grab somebody, and but I can't answer a question until I figure out what all of these sections are. So, what did we do when we did a couple of these before? What did we do?
Just trial and error.
No. Now, would trial and error work? Yeah, but probably not when you're this is gonna be a big test. A lot of questions. Probably wouldn't want a trial and error, but trial and error will always eventually work. No, I don't think trial and error is the way to go. So, I don't know what these 3 sections are. But I do know that the whole C ball adds up to 20. So 6 plus X plus 3 plus Y is 20. And Y plus 3 plus Z plus 10 is 22. And X plus 3 plus Z plus 1 is 16. So that I do know. I'm gonna clean these up a little bit. X plus Y equals 11. Y plus Z equals 9. Keep an eye on my arithmetic. and x plus z equals 12. Now, you could solve this lots of different ways, but in this kind of problem, they're always really easy to eliminate because all of your variables are plain x's and plain y's. So it's just easy to eliminate. If I multiply this one by a negative, for example, this is gonna be, those are gonna cancel, and I'm gonna have x minus z equals 2. But I know x plus z is 12. Are you following along here, guys? So 2x equals 14, so it looks like x equals 7. And if x is 7, then y has to be 4. And if x is 7, z has to be 5. Now, what do all those add up to? All these right here. That's 20, 30, 35, 36. So what does that mean? If there's 36 people in the circles, then there's 4 that when you ask them what kind of music they like, they said none of these. And then the question ultimately is, reach in, grab one kid out of this box. What's the probability he won't like any of the music? 4 out of 40 or 1/10?
Are we doing it again tomorrow?
I will do something tomorrow.
Please come another lesson. Wait, this is the last one.
Okay, so anything else on this page? All right, let's go to the last page, which is the back of the second page. So what do we have here? Let's find the limits in number 32, because we can do that without too much work, and some of us missed that on our homework. All right, so here we go, we're finding the limits. What's the limit of A? Some of these might not have a limit, by the way. The limit's 1. How about B? 0.
Wait,
C?
no. Wait,
No
how did you
limit.
do the limit of?
Why does C have no limit? Because the top has a 1 n squared and the bottom has no n squareds. So that
This is the hop.
is just going bigger and bigger and bigger and bigger. All right, what about D?
Zero.
0. 0 is a limit. Don't say no limit. 0 is a limit. Why is the limit of D 0? You're going smaller, 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 smaller. Every time you multiply by 3/4, you get smaller, right?
Wait, is that the same as like for B, the limit is 0 because is it
You have no n squareds over 1 n squared. That's exactly what we did with horizontal asymptotes. 0 over 1. 0. We'll probably run into one of those. What about E?
Because it can't be negative. Yeah. What?
well, it could be.
But it can't be 0. Oh wait, is it
The
negative
limit's
1?
0. The limit's 0. You guys, what happens to 1/4 as you raise it to higher powers? It gets smaller. Timesing 0 by 5, does that change anything? Nothing. The limit is 0 for number, or for letter E. What about F? 3/2. What about G? No limit. Because 6/5 is bigger than 1, and when your ratio is bigger than 1, the terms are just getting bigger. All right, H? 0. Because what is H? Another way of thinking of H would be 1 over n. So think about those terms. 1 over n would be 1, 1/2, 1/3, 1/4. What's happening? Going to 0. Going to 0. Okay, now what's happening in this one? I.
Infinity?
I heard somebody say one. Why did you think it was one? Who said that? Why do you think it was one?
It already
Zero looks
exceeds
like it
one.
keeps getting like, isn't it zero?
Wait, but it already.
Okay, so if you think about it, isn't your denominator just the counting numbers, 1, 2, 3, 4, 5? And what's your numerator? 2 more than that? Isn't that what's happening? So we have n over n, and that is 1. Now, Josh, what you were thinking about is fine. I would probably take my calculator out and look at those things as decimals, because I have 3, 2, 1.6, 1.5, and they're gonna be getting, you know, smaller and smaller and smaller, but since the top is always bigger than the bottom, it's always gonna stay more than 1. It's just gonna get smaller, but more than 1.
So my problem.
Okay, what about J?
You can't. It's literally like from Mean Girls. I just.
J is gonna be whatever 5, 6 plus 3 sevenths is,
53 and 40 seconds.
which is 35 and 18, 53 over 42. That's exactly right, that'll be the limit. Because we find the limit of each piece and add them together.
What is the limit again?
It's the number that you approach as you keep going. If you just keep letting n be bigger and bigger and bigger,
The number that you.
keep getting closer to it. So 1,002 over 1,000. 1,000,002 over 1,000,000. Those are getting closer to 1. They're never going past 1.
Okay, but I literally is. I get that you separated the bottom and the top. I don't.
Huh? I don't know what problem you're looking at.
An
Cecilia.
I.
Get,
Oh, the
get out your
limit.
calculator. Get out your calculator. Start typing those fractions in. What's happening to them? And then you don't have to use just those. Let
So
the
getting
numerator.
closer to
If the
one.
numerator is 100, the denominator would be
So getting
98.
closer to the top.
Yeah. Yeah. That's exactly right. Whatever they're getting closer to is the limit. All right. Anything else on this page?
35.
Yeah.
What arithmetic means are we have 5, then we have, how many we putting in there? 4. And then we have 20. So basically it means you've got an arithmetic sequence. You know what the first term is, and you know what another term is, and you're putting 4 in between. Those are called means, but it could be geometric also. They tell you this one's arithmetic, but you could do exactly the same thing with the geometric one. So we talked about this before. If this is arithmetic, then we have to add 1, 2, 3, 4, 5 times. And that has to be totaled up 15. So 1, 2, 3, 4, 5 additions. D plus D plus D 5 times has to add up to 15. So if 5 additions have to be 15, then each addition is 3. So your numbers would be 8, 11, 14, and 17. Those are the 4. Could we do 5 numbers in there, 8 numbers in there? Yeah. Exactly the same thing no matter what.
We just go, like, I just have a question about finding, the limits.
And I have a question for you. Have you watched all the class videos?
Yes.
You have?
Yes,
And
it's
your
just,
notes are all complete?
yes.
Okay, all right.
It's just like, I know it's the same thing we did with, like, asymptotes, but can you just remind me, like,
You look at the highest power, Miriam. The highest power in the problem.
okay,
If they match, then it's that ratio. 7n over 5n is 7/5. If the top one's smaller, then it's 0, because you have no n squareds and n squareds on the bottom. If the bottom one's smaller, then it's no limit, because the top is something and the bottom is 0. Okay?
so if the top is less than the bottom, it's 0, and if the top is, wait,
Yeah.
sorry.
And no, you said it right, but ideally you would understand that if the power on the bottom is bigger than the power on top, what is happening to that fraction? It's getting smaller. So the limit's gonna be 0.
Okay,
Think of 100 over 1,000. think of 10 million over whatever, 100 million, or whatever, it'd be even more than that, whatever it is. It's just getting smaller.
Could we do number 36?
Last one, 36. All right, we did this actually yesterday. Or one like it. So we have a ball drop from a height of 50 inches. Each time it hits the ground, it bounces back up
Oh, yeah.
2/3 of the distance it fell. So if we look at this bouncing ball, dropped from 50, this is gonna be 50 times 2/3, and so will this one be, because it's gonna fall down that much. This will be 50 times another 2/3, and so on and so on and so on. So who remembers how we did this yesterday? Or let it go until it comes to rest. Oh wait, let's do B first, because that's the question I just asked, and then we'll do A. How far does it travel before coming to rest? That's exactly what we did yesterday. What did we do?
We're down.
So we looked at the downs. This is really not a sequence, because you've got repeated terms in there, so you have to kind of separate it. So if we look at the downs, the sum will be the first term over 1 minus the ratio. So I think that's 150. 50 over 1/3. What does that 150 mean? That means this, plus this, plus this, and this, and this, and this, all add up to 150. So what about the ups then? They are gonna be exactly the same thing without this initial 50. So the total distance it travels is 250. Now that's question B. Question A, how high does it go after it hits the 6th time? Well, this is how high it goes after it hits the first time. This is how high it goes after it hits the 2nd time. So what do you think it's gonna be after it hits the 6th time?
50 times 2/3.
50 times 2/3 to the 6th. And you'll just type that in, and whatever decimal that is, that's how high it goes after it hits the 6th time. Okay? So tomorrow I will have to hand back all the quizzes. I meant to do that today, but there's really no point in it.